Ребята, всем привет! Рад приветствовать вас на втором дне конференции VideoTech 2023. У нас сегодня с вами очень интересный гость. Это доктор Jianhua Zheng из Пекинского университета с докладом о новом китайском кодеке AVS3. Этот кодек, собственно, ну, как вы можете сделать вывод, не первый в серии кодеков AVS. Доктор Jianhua, он, собственно, является представителем комитета, китайского комитета телевещания и стандартизации аудио- и видеокодеков, которые этот кодек разрабатывает. So, Dr. Jinhua, we are starting. You're right now from Beijing, right?
Yeah, I'm in Beijing.
Oh, nice, nice. So I've made the introduction for the audience, and I think you can start the presentation.
Thank you. Thank you, Rusty. Thank you, everybody. It's my first time to attend a VideoTech conference. I'm very happy to meet all of you, and I'm very happy to introduce AVS3 into a VideoTech expert. So this is my talk. For today's talk, titled as AVS3 enabling the efficient video delivery for UHD broadcasting and streaming. So I'll list my contact email in this cover page. So if any questions after this session, you can contact me, and I'm happy to answer your questions. So let me have a brief introduction on myself. I work for video coding standardization work for over 18 years, and also serve as a co-chair AVS Video Group, leading the development of AVS2 since 2015, and leading the development of AVS3 work since 2019. And I currently is the distinguished researcher in Peking University, and also serve as the chair of the AVS International Communication and Promotion Group. So this is outline of my talk today. I want to first give the brief introduction of AVS Working Group, give the background of the AVS Working Group, and after that I will have a brief overview of AVS standards. After that, I will introduce the AVS3 key features, test results, and the deployments in China, and the licensing program for AVS standards. So in the last, I will introduce the international cooperation between the AVS and other standard organization. So first is the background information on AVS. Maybe you already know AVS' short name is the Audio Video Coding Standard Working Group of China. So AVS is not only one standard; it's a series standards to cover the video audio system and many public standards in AVS in past 20 years. For video standard, we have three generation standards. The first one is AVS1, start in 2002, over 20 years, kick off this work. And AVS2 start in 2012, and AVS3 start in 2018. So we currently have developed three generation standards for video, and we also have audio and other system and technologies for in AVS Working Group. AVS is also strongly support over 100 AVS members coming from all over the world, including the manufacturers, SoC vendors, and operators, and so on. And AVS video coding standard has been widely used in China. In China, for UHD broadcasting, we already use AVS Plus since 2012, and for 4K broadcasting, we use AVS2 since 2016. And currently, we use AVS3 for 8K in China for the 8K trials. And internationally, AVS also expanded outside deployment in some countries outside China, such as Laos, Thailand, Cuba, Kazakhstan. So AVS not only deployed in China in past 20 years. In China, AVS3 is also the key enabler for AK-12 in China, and in past 2 years for the Peking Winter Olympics and the Qatar World Cup, we already have AVS3 trials for broadcasting and for the live streaming. Okay, this slide gives the structure of AVS Workgroup. So AVS Workgroup has many subgroups, and for the requirement group, the first group is just to just to receive the industry commercial requirement from industry. If all the commercial requirement has been graded by the AVS group, so they can deliver to set up work item to technical groups. So for technical group, we have a couple of technical group in AVS work group. For system, video, audio, this group are technical group. For the video, we have also set up the ad hocs in video groups. For AVS3, in the past several years, we have completed AVS3 phase 1, phase 2, and currently we also developed the range extension for AVS3. And the new work is item is AVS4. This is the next generation beyond AVS3, and this work is kick off in earlier of this year. And we also have AI codec ad hoc that to develop the end-to-end AI codecs that include the image AI codec and include the video codec. For AI codec, there's different framework to the previous traditional video codec. That's a new one, new work item. And we also have AVS PLC. The PLC means the perceptual lossless coding. This is for the interface video delivery and for the program production. And we also have VR Preview 360 subgroup to develop the VR application. So currently, AVS members are coming from the worldwide industry, and the major AVS members are coming from the China mainland. But we also have a couple of industry members from the worldwide, such as Sony, Samsung, LG, Intel, VideoTech, AM Logic. They are also the worldwide famous industry company that joins the AVS standard work. So in this page, I want to illustrate how AVS makes specifications. So we have a requirement subgroup. This group to discuss the commercial requirements. If we requirement subgroup receives a commercial requirement from industry, so they will join a discussion with technical group and make a decision what kind of commercial requirement we will make and we will create to set up a new work item. If this requirement is great, then this work will be delivered to a technical group. So in technical group, the usual procedure for the standardization is the first to release a call for evidence. If evidence to show that it is good, the result is good, that to kick off new standards, then we will release the call for proposal. The call for proposal, the call for evidence may have several cycles. If we receive the response from AVS members, we can decide in technical group, subgroup, which proposal, which response is best, and maybe to merge the different response for AVS member to have a better result. So after that, we will work for the working draft for AVS standards. maybe working draft have many cycles, working draft 1, working draft 2, and finally we will get the committee draft. Maybe this will have 1 year or 2 years or 3 years to have a committee draft. After committee draft, that means all the features, technical features, should be fixed. So if this committee draft have achieved in the technical group will have a joint meeting with the requirement group to decide if this standard, this specification, has met all the commercial requirements from the previous design. If this conclusion is all the commercial requirements has met, so we can make the committee draft as the final committee draft and submit to the communal group. So a communal group will decide and release the draft standards for AVS member for the continued review in AVS members. The review period usually is 3 months. So after that, maybe we receive some comments from AVS members, so we can have a minor revise to the standards, and if all the members have the comments have been revised into the spec and no further comments, we can release the draft standards and apply to the AVS and submit the draft standard to AVS industry lines and publish by AVS industry lines as the AVS standard. So this standard will be published in AVS website. And in the meanwhile, we will also submit the standard to Chinese Broadcasting Industry Standard Committee. So that means we will have this AVS standard to become as the Chinese Broadcasting Industry Standards. And meanwhile, we'll also submit this standard to Chinese National Standard Committee to become as the Chinese national standard. But the Chinese national standard procedure will need a very long time, maybe need 2 years, 3 years after the standard is finalized. So for AVS specification, this is usually standardization procedure, and we have a formal AVS meeting per year. Usually happen in March, in June, in August, in December. And before each meeting, a formal meeting, we have a meeting notice before that. All the meeting notice is published as both English and Chinese version, so you can easily to attend that even for the non-Chinese speakers. And AVS also have a proposal website to allow the AVS member to submit proposal and registration for all the proposal for the AVS meetings. For proposal, we allow the proposal can be drafted as both Chinese language or English language. This is all allowed. And for the discussion during the AVS meeting, both Chinese and English language are allowed. But the specification for the final specification is we need to draft as Chinese. So Chinese specification is as the first, and after that we will have an English version, corresponding English version published. So this is the usually stage of AVS standardization. So next, I want to have a brief overview of AVS3 standards. As you already know, AVS3 have AVS standard, video standard has 3 standardizations. The first is AVS1, or also known as AVS Plus. It has been used for HD broadcasting in China. And AVS2 has used for 4K broadcasting, and AVS3 has finalized in 2022. Have been already used in 8K broadcasting in China. But all the AVS video standards that has the general rule for for standard. So AVS standard only designed to use the technology from AVS members only. And we use the royalty-free technology. So we should keep this very seriously to keep the AVS standard is safe to be deployed in industry. Okay, this is a timeline of AVS standards. Actually, AVS working group has set up over 20 years. It started in 2002, and now is 21 years after AVS set up. So for AVS standards, we usually publish as AVS website, and it also submit to AVS. Submit to Chinese broadcasting and publish the Sept standard. So Sept is the Chinese Chinese government standards that is for broadcasting. So currently is changed NRTA, changed its name as NRTA. And AVS also submit the standard to IEEE Society. Standard Society and publish IEEE standards. So all the IEEE standard is published as English. So this figure to illustrate the relations of AVS standards and to other video standard developed by other organizations. So as you already know, MPEG and ITU has joined developed the MPEG series standards. The latest standard is VVC VVC and EVC, and for the AOM it also developed AV1. For AVS we developed AVS3. So the four standards, video standards, codec standards, are the candidate for the industry deployment. We consider it as the same generation standards. Okay, so actually AVS standard deployment is happened in 2017. It has two phases for AVS3 standard development. The first phase we called as main profile is finalized in 2019. The target is to achieve the good trade-off between the complexity increase in encoding gain, and we already know from test results, we know AVS main profile achieves 28% coding gain over HEVC for 4K. And based on main profile, we developed AVS high profile. It's finalized in 2021. It will continue the coding efficiency, and from test results, we know 40 coding gain, compared to HEVC for 4K. So this is a timeline of the AVS3 standard development. Beyond AVS3 finalized in 2 years ago, we already collaboration proposed AVS standard, video standard to DVB. And DVB in last year has published the DVB standard to reference AVS3 video standards. And in this year, in July, the DVB SA standards have been published. Okay, next I will want to introduce the features of AVS3. The first is the AVS3 main profile. I list some of the key tools in AVS3 main profile. So actually, AVS framework is very similar to previous standard AVS2 standards and previous standards. And the framework is to optimize to introduce the new block partition. The basis is the core tree. Core tree binary partition is contribute to the new coding gain. We also have some developed new tools like EQT, DT that to extend the block partition to bring more attention to coding gain. For interpretation, we also introduce the new tools on that to improve the AVS coding gain. So that is the AVS coding tools in the AVS main profile. In the right side of this slide, you have some. You may notice some gears. So the large gears means indicates they have contributed to the large coding gain in the AVS main profile. So you can see that for the broad partition, this contributes to the largest coding gain, and the transform consolidation entropy coding, this is contributes a certain level of coding gain. And based on main profile, we also introduced the new tools and developed the AVS3 high profile. So high profile tools is some different to the main profile, but we have the basic rule that AVS3 high profile is backward compatible to AVS main profile. So for the industry deployments, all the AVS high profile decoder should decode the AVS3 main profile streams. And in AVS3 high profile, we also support the string content coding. Okay, you may have interest to compare that we have some coding standard from different organizations. So actually, in several years ago, in PCS 2019, there are interesting discussion, the panel discussion on the different standards for the new generation standards to compare the AVS3, VVC, and VV1. So this panel discussion is to invite the expert from the AVS, from the JVS, from the AOM expert to discuss the future comparison, discuss the performance. So that's this panel discussion is very interesting to the future comparison between the three codecs, new codecs. So this figure to list the table to list the different category toolbox tools in the three codecs. So you have more interesting to this comparison. You can refer to the PCS and get the paper download and have more detail on that. Okay, next is the AVS3 profiles and levels. So we currently have a main profile and a high profile, and both support the 8 bits and 10 bits. So this is a basic profile we deployed in industry, and we currently develop the extension profile to do the extension development. Sorry, to support 444, 444, 422, 12-bit, 6-bit. And for levels, we have defined a couple levels to support HD, 4K, and 8K. For the main features such as HDR, we support PQ, HLG signaling in the AVS streams, and we also support the color gamut like BT 2020, BT 709, and we also support the progress and the interlaced coding. For interlaced coding, because there's some requirements to support AVS3 for backward to the HD application. So this is the requirement from industry. For the standard design, we did not include new tools for the interlaced tools. Just to use the progress coding tools to support interlaced sequence. Okay, next I will want to give some test results. The first is to give the result on the AVS3 main profile. In this figure, this slide, I use the AVS3 open source comparison between the AVS3 open source and the A1 open source and HEVC HM reference software. So the left table using the AVS open source UAVS3E This open source can be downloadable from AVS website. It's the public downloadable and no any restriction. And also, I have a link for this in the bottom of this slide. So if more details, you can refer to this website to have look to study the comparison detail. This work is complete in 3 years ago. So maybe the AV1 reference software may not update. Its version is published at same time as the AVS3 main profile. So from the comparison results compared to HEVC, we can look at for 28% coding gain compared to HEVC reference software. And from compared to A1, we observed around 8.8% in the Luma. So this is the performance of AVS3 main profile. And this slide just shows one figure comparison for the subjective comparison between the UAVS3E and the XL265. So you can look at the figure in the round circle that the quality is improved. Okay, the next is AVS3 high-profile performance. In this slide, I use the AVS reference software and compare to the HEVC reference software. So AVS have developed a software as APM. The version I use this comparison is 12.12, HPM 12.2. And HEVC reference software we use HM 16.22. These two tables is to compare the AVS3 high profile to the HEVC on 4K, HD, and 8K. So we can easily from this table to know that compared to HEVC on 4K, AVS3 have observed 40 Y-way coding gain. And on HD, is coding gain is 35, and for 8K coding gain is 35. So the coding gain is compared using the average PNSR number, and this calculation of average PNSR is follow the ITU standards. So next is AVS performance, performance on the interlace coding to support interlace coding. So this is the requirement from industry to try to apply the AVS3 to be used in HD content. So in HD content is in some countries they're still using the interlaced sequence. So we conduct this test to compare the AVS3 main profile high profile compared to HEVC. The two tables in the left side of the slide is the AVS3 high profile, and in the right side, two table in the right side is the AVS3 main profile compared to HEVC. So you can clearly to see that for AVS3 high profile, we achieved 41% coding gain compared to HEVC at the GOP32, and for the main profile, we achieved 32 coding gain compared to HEVC. For the GOP16, the coding gain has some drops, 1 or 2% coding gain drops compared to GOP32. Okay, next is the deployment of AVS3. So AVS3 have been largely supported by AVS members. For AVS 4K, 8K vendors, it's a money supporter to develop AVS products. For AVS hardware encoder, we have 3 encoders in China. Arc Video and Suma Vision and Boya Racing provides the AVS3 professional hardware encoder to industry. And for the chip design, we have already have 4 SoC vendors to support AVS3. High Silicon and Guoke Microval and VideoTech and MediaTek and AM Logic already released their chipsets. Both include the STB and the TV SoC to support AVS3. And for the set-top box for 4K, 8K, we have many manufacturers to support provide the products for AVS3, include Hisense, Changhong, Unit, Fair Home, and Inspire. So this set-top box also available in Chinese market and have been tested in the AVS3 trials in China. And for the TV, we have 5 manufacturers to release the AVS3 products. TCL, Xiaomi, Qualcomm, Honor, Hisense. They also have products in China mainland and outside China. Okay, for the deployments, the very important thing to develop the conformance streams. So Angola DVT is very important in this area, and they have released the AVS3 main profile conformance streams in 2019. So you can go to the Angola DVT website to have this commercial stream. You have developed AVS3 products. And the AVS working group also developed conformance streams. That is joint developed by AVS Central Alliance and AVS working group. And this conformance stream is stored in AVS FTP. But this stream is only available for AVS members. You have any interest in, you can contact AVS Central Alliance. We can try to provide this stream to you. For the AVS3 V and V streams, in the past 2 years, AVS working group and has collaboration with the DVB to develop the AVS3 V and V streams. These streams also published in DVB website. This is publicly available, publicly downloadable. And AVS3 also has some bitstream tools to support for AVS3 analysis. Commercial tools, we currently have 3 companies to support AVS3. Adcar from Russia, its tools is a stream analyzer, and the DevTech from UK is stream expert, and Microsoft from Cyprus is tools is Vico analyzer. They both support AVS3 TS and stream analysis. And we also have open source to support the AVS3 analysis that includes the TSR, DVB Inspector, FMPEG. Okay, so actually, after AVS3 main profile finalized in 2019, we kick off the industry broadcasting trial in China. The first domestic AK trials in China is happened in Suzhou in 2020. The operator is Suzhou Cable, and they use AVS3, use AVS3 AK, and they use the DVB-C for broadcasting. And the second broadcast event is trial is launched by CMG CCTV. They launched the AVS3 AK trial channel for 3 Spring Festival events in 2021. And over 70 cities in China have received this signal, and over 500 outdoor screens have connected. So the third big event in China for the AVS3 broadcasting event is happened in 2022. for the Beijing Winter Olympic Games. In these Olympic Games, we first using the AK live broadcasting launched by CCTV, and we also first launched the AVS3 mobile live streaming. The operator is China Mobile. And in end of last year, in Qatar World Cup, China Mobile also launched AVS Mobile Live for this event, and over 200 different mobile phones have been tested as the user devices, and over 25 live broadcasting games using AVS3 for the trials. In this year, just happened in September this year, in Hangzhou, the 19th Asian Games. We also have AK broadcasting and mobile live streaming trials in China. So this also the operator also for the CMG and China Mobile. So AVS also developed open source for industry. So in AVS working group, we have a reference software that we call it as HPM, but that's different to the open source. The open source has more focus on the performance and focus on the optimization for the deployments. So we also developed AVS open source and public available from the GitHub and in the AVS website. In FMPEG, we also integrate AVS3 memprofile decoder in FMPEG. So the latest version includes the AVS3 memprofile decoder since the 2020. In this figure, we also compare the open source performance with the A1 open source. This is some results. You can refer to the ecosystem.avs.org.cn. Have more details on the comparison. Next is the most interesting, maybe licensing program. All the information actually is published in AVS website. You can refer to this website for more details. But in general speaking, is that AVS have a lower risk features and simple license features. So lower risk features that indicate we have upfront commitment to license. That means if any proposal by the contributor to somebody to the AVS, they should have upfront commitment to say they have agreed to license their API to AVS working group. So that's a different standard model to other organizations. For simple license, we mean that usually for the previous AVS 1, AVS 2 standards, we have 1 RMB royalty fee for each codec, and we have annually royalty cap, and so this is a very simple license of compared to other standards. So this figure just to summarize the AVS IPR policy. The general policy is AVS standard only use AVS member technologies or the royalty-free technologies. So that's different to other standard organizations. For the contributor to the AVS standard, they have 3 selection. So you can select the RAND RF, you can select join the AVS patent pool, or you can select give the RAND to AVS standards. But the RAND RF and the joint AVS patent pool is the most favorable to AVS standard adoption. So if we consider the potential technology to be adopted in AVS standards, RAND RF and the joint AVS patent pool have a higher priority to other selections. For AVS IPR, since we have a simple license model that we have only one patent pool, we have one style license model, we have all 1 RMB for hardware decoder, and for software decoder implemented for internet application that is router free, and we also router free for content provider. Okay, next is international cooperation. In the past 3 years, AVS has set up a good collaboration with DVB, and now AVS DVB has signed the formal license cooperation in this year, in May this year. In the past 3 years, we have successfully cooperated to work the new DVB standards, IC standards, and have AVS3 become the into the DVB next generation video coding standards, have been the one candidate in the DVB as same as VVC. Why we select DVB? Because we think DVB has widely used in worldwide, include the US and Japan, and for DVB-T, DVB-T2, DVS, DVS2 is widely used in past 30 years, and currently a new DVB standard, DVI, is coming. We consider it has more potential to be used in China. It is more and it is favorable to IP-based transmission. In past 3 years, we have 3 DVB axis specifications relevant to AVS3 and refer to reference to AVS3. So first is DVB AVC. In DVB, we also call it as codec toolbox. This is the usage of the video audio coding in DVB standard system. The spec number is TS11144, and also published in IC in July this year. And the second standard is the DV dash. Is the DV dash profile for the IP-based networks using the SOBMF using the dash. So this standard has reference to AVS3 and also published in September this year. And third standard is the DVB-SI. DVB-SI is the specification for service information in DVB system for transport broadcasting. So this standard is published in DVB, but the active publication is expected in next year, in the middle of next year. All the 3 DVB specification has reference to 2 AVS standards. AVS3 Part 2 is AVS radio, and AVS3 Part 6 is the field format for AVS radio. So in DVB-SA, they follow the codec toolbox rules. Before AVS addition to the DVB toolbox, they already followed MPEG codecs that already include MPEG 2, 8.265, 8.64 codec in the toolbox, and they recently to add AVS3 and VVC into the codec toolbox. And A1 and LCEVC is currently in the phase 2 study, and currently have no final decision on these two candidates. So in AVS specification reference in DVB UHD TV standards, we have defined the 4 profiles for IRD profiles in DVB ecosystem. This figure just shows the relations of the 4 profiles. In this figure, UHD-TV1 means the 4K, UHD-TV2 means 8K. So this is the relation between the 4 profiles in DVB ecosystem. And DVB and AVS has collaboration to jointly develop the AVS3 verification, validation, streams that targeted for the usage in AVS3 in TS and dash application. And all the streams had already publicly available and published in DVB website. So if you have want to test your product, you can refer to the DVB site and download this stream for your product testing. Okay, and in this slide, I just want to make a relation how the AVS standards and the DVB standards build relations. So in DVB, we already have a 3 standard reference to AVS. In AVS3, we have AVS3 P2. That is the AVS3 video. It includes the AVS main profile, high profile specified in these standards. And we also have AVS3 Part 6. Part 6 is the media field format. This is published in 2022. It includes ISO bitmap, CMAF, the field format, and include the dash, and include the MPTS, include the SMP transport protocol to specify in this Part 6 standards. So these 2 standards are already specified in AVS and reference to DVB standards. And we also developed the AVS3 TS guideline. This currently is a guideline and published in AVS website. And based on these standards, AVS DVB has developed the V and V conformance streams. That for 8K and 4K streams for TS dash streams, this is you can use this stream site. It covers TS, covers the CMAP dash format. Okay, this is all the. Okay, this is all. This is all. Thank you very much.
Thank you very much, Dr. Jianhua. It's a very interesting and very technical talk. So once again, thank you so much.